The process of creating an image using 3D software is computationally intensive. That is to say, it takes a lot of computing power to generate that image. In the early days of the development of 3D software, engineers were severely limited by the strength of computers of their day. In response, the software they created to render 3D space, called the render engine, incorporated a lot of visual and mathematical simplifications of the real-world situations they were trying to produce. These adaptations by the early programmers dominate how all current 3D software behaves, regardless of what company makes it. In the real world, our eyes perceive the world around us not by the objects themselves, but by the photons that bounce off of them. So photons travel from a light source through space and they hit a surface and they bounce off of that surface, and they may bounce off of many surfaces and eventually land on our eyeball. Our eyeball then interprets those photons as images. The wavelength of light that the object bounces is what determines the color that we perceive. So the amount of photons that exist in reality is way beyond any computer that is currently available or may ever be available to accurately calculate. And so the software engineers came up with the idea of rays. And rays sort of behave like photons, but not really. What they do, though, is they allow the render engine to see objects in the scene. And so I have a very simple scene here. I've got a sphere, and I have a camera and a light. And there's rays that emit from both of these types of objects. Keep in mind, this is a gross oversimplification of how the render engine works, and I'm sure a programmer would cringe at the way I'm explaining it. But I really want you to understand not the technical aspects, but really what's happening in the render engine. So if I hit play here, I've set up a little animation that illustrates the idea of how these rays emit. So when I hit the render button, this would happen. And these lines that we see in the scene here represent those rays. And so we have rays that emit from the camera point of view, and we have rays that emit from the light's point of view. And those rays go into the scene and they strike an object. You can see they're hitting our sphere here. And if I switch to look through the camera, some of those rays are traveling off into space, and some of those rays are making contact with the sphere. The rays that travel off into space, they never come back to the render engine. They produce black around the image. The rays that hit the sphere, they tell the render engine a lot of information about that sphere, and they say, hey, there's light coming from this angle. It has a material on it that has this color associated with it. Therefore, you should draw a pixel at this location on screen of this RGB value. And that's what the render engine does a zillion times when you hit that render button. So when I hit this white clapboard here, which is the render in active view button, you can see that I get this beautifully rendered sphere with black around it. And all of that is based on those calculations, which are once again designed to simulate what happens in the real world. With a basic understanding of how a 3D render engine works, an artist can get tremendous control over the creation of 3D stills and animation.